Hey everybody. Alright, so our next lesson with transformations. So we just got done talking about horizontal and vertical shifting. Okay, so now we're going to start talking about reflecting. So if I have a parent function and I want to reflect it, how am I going to do that? Okay, so there's actually three different ways that we can reflect a graph. Well, there's lots of different ways, but three main ways that we're going to talk about. So instead of just telling you the first way, so I'm not going to tell you what it is yet, TBD. So let's see if we can figure it out on our own. So let's start with some function f of x. And I'm just going to start by drawing it and see if we can figure this out on our own. So let's say here's my graph. And let's say that this graph is part of my x squared graph, but I'm only going to draw the right half, and I'll show you why here in a little bit. So if I was going to make just a little table here, let's have 0, 0, 1, 1, 2, 4, 3, 9, and that's probably pretty good. Okay, so here's our function. It's a part of our x squared function, but it doesn't really matter what it is. It's just some function f of x. All right, so here's what I want to do to f of x. I'm going to create a new function, and to create this new function, I'm going to throw a negative out in front of my f of x, and I'm going to call this new function g of x. Okay, so my new function g of x is going to be equal to negative f of x. All right, now what does this negative mean? What is this negative impacting? Well, it's out in front of the whole thing. So this negative is impacting my outputs. Okay, so if I wanted to create a new function, g of x, how am I going to come up with my table for g of x? Are my inputs going to change or are my outputs going to change? So my inputs are going to stay the exact same because all I'm doing is I'm leaving the same inputs, x and x, but I'm going to take the old outputs and just change the sign, and I'm going to have my new function. So on my new table, this would be 0, 1, 2, 3. The inputs don't change here, but my outputs are going to be the opposite of whatever these were. So these, starting with 0, well, negative 0 is just 0. These are all positive, which means they're all going to become negative. Now, if any of these started as negative, then we would just switch them to be positive. So this doesn't necessarily mean the outputs have to be negative. Really what that's saying is the outputs have the opposite sign as they used to. Okay, so let's go ahead and plot these points and see where we're at. So 0, 0. So 1, negative 1. 2, negative 4. 3, negative 9. Pretend like I hit all my dots. And there we go. Okay, so what happened here? What did you see when we threw a negative out in front of the whole function? And what you should have seen, and if I drew a little bit more precise, is this was a reflection over what? Over the x-axis. Okay, so the first way we can reflect a graph is we can reflect over the x-axis. Okay, and how do I do that? I do that by taking a negative and putting it out in front of the entire function. Okay, now the alternative to this, and we'll show you in a second, we're going to put a negative right next to the input value. So in input value, we can put a negative in front of that, or output value, we can put it out in front of the entire function. Okay, we'll do some examples. So your first one is throwing a negative out in front of everything, and that's going to give me a reflection over the x-axis. And why does that happen? Because all my output values used to be positive, and now they're negative. Okay, so I cleared the board here. So the first way was reflection over the x-axis. So the second way, you can probably guess, so I won't make you wait. So the second way is going to be a reflection over the y-axis. Okay, so try to think about why this makes some sense with what before I kind of talk about the equations and stuff like that. So I kind of spoiled it for you. If my equation is f of x, so this function is f, what we're going to try to do is we're going to throw a negative in front of the input values, and then we're going to get my new function, and we're going to call it g of x. Okay, so we started with f of x. Here it is. Here's my table for f of x. And now we're going to try to create this new function, g of x, by taking a negative and throwing it in front of my input values. Okay, so go ahead and see if you can pause the video and make your new table for g of x based on our definition here. So ready? Pause. Okay, so what am I going to do here? Well, my rule says take all the inputs and then just change their sign, make them opposite. So 0 stays the same, but instead of positive 1, we have negative 1, negative 2, negative 3. Okay, now what does it say to do with the output values? Do I make them negative? Well, all this rule says is when I change the input values, I'm going to get my new function. Okay, so I'm not going to change the output values. There's no negative out in front telling me to change the output values. There's only a negative on the inputs telling me to change my input values. So on this table, I'm going to keep all my input values the same. That's what my rules tell me to do. Okay, so if I go and plot these points, negative 1, 1, negative 2, 4, negative 3, 9, a little bit better that time. So there's my function. This is g. We found it. Okay, so what do we notice about this? We notice that g is a reflection over the y-axis of my original f function. Okay, so if I take a negative and I throw it in front of the input values, I'm going to get a reflection over the y-axis. Okay, and then the third type of reflection we can have is we can reflect over the origin. Okay, now it's hard to kind of know what that means because the origin is just a point, right? How can you reflect over a point? So really what this is saying, reflect over the origin, this is really saying reflect over the x-axis and the y-axis. Okay, so if I want to reflect it over the origin, I'm going to reflect it over the x-axis and the y-axis. Now, does the order matter? No, it doesn't. And I can show you why here in a second. Now, we have a rule for this one as well, but instead of telling you the rule first, I'm going to show you what the graph looks like and see if we can kind of come up with the rule again. Okay, so I'm going to go ahead and start by reflecting this graph over the x-axis first. Now, if you want to, just to prove it to yourself, you can reflect over the y-axis first, and we're going to end up with the same graph. Okay, so there's my red graph. You can see this is a reflection over the x-axis. All right, now I'm going to take this graph, and I'm going to reflect over the y-axis, because that's what we said. Reflection over the origin means reflect over the x-axis and the y-axis. So I'm going to take this red graph, and I'm going to go ahead and reflect him over the y-axis. And there we go. We get our final blue graph here. Okay, so this blue graph, we're going to call him g of x. This is g. So if you did the other order, I don't know that this green marker is going to show up too well, but if I take this original graph and I reflect it over the y-axis first, we will get this green graph. And then if I reflect over the x-axis, you can see that I end up at the same place. Okay? So when I reflect my graph over the origin, which means over the x-axis and the y-axis, I can do either one first. It doesn't matter as long as I get there eventually. Okay? Now, some people do get this confused with the reflection over the line y equals x. It is not the same thing as that. Okay? So that's a different reflection. If you remember reflecting over the line y equals x, that actually finds the inverse of the function for us, which is different than reflecting it over the origin. Okay? So the last thing we have to talk about here is, what do I do to my f of x equation to come up with this g of x graph? So what did I do with f that turned it into g? So to help me with that, I'm going to go ahead and plot these points, make a table, and see if I can find a relationship. So the g has the point 0, 0. It also has the point -1, -1. It also has the point -2, -4, and the point -3, -9. So what's happening here? How did I get from f to g? Well, you may have seen all my inputs are opposite, and all my outputs are opposite. Okay? Which, if you think about it, that makes sense, because to reflect it over the x-axis, we said we make the outputs negative. To reflect over the y-axis, we make the inputs negative. So if I want to do both, reflect over the x and the y-axis, then it makes sense that I put a negative on both. And that's exactly what we do. Okay, so here's a summary of what we've learned so far today. So if I throw a negative out in front of the function, affecting the outputs, that's going to be a reflection over the x-axis. If I throw a negative in front of the inputs, that's going to be a reflection over the y-axis. And if I throw a negative in front of both, then that's going to be a reflection over the origin. Okay, so how are we going to use this? Well, let's do an example. So let's say you wanted to graph the function negative square root of x. Okay, I want to graph this. I don't want to use a calculator. I just want to use my brain here. So first thing you ask yourself is, what is my parent function? So hopefully you recognize your parent function is the square root of x. Even more so than just knowing that, hopefully you know what it looks like. So this would be my parent function. This is the square root of x. Okay? So if I want to graph negative square root of x, I have to be able to recognize, what am I doing to this function? What does that negative do? So the negative is out in front of the whole function. Square root of x, all I did is I took a negative and I put it out in front of the function. So which reflection am I actually going to be doing here? So it's out in front, so this is reflection over the x-axis. And so if I want to graph negative f of x, all I have to do is take this graph and just reflect it over the x-axis. And boom, there you go. And that was a pretty bad reflection of bridge. But you guys get the idea. So it's a reflection over the x-axis. Okay, so let's try another one. So f of x equals 2 to the negative x. So step 1, who's my parent function? My parent function is 2 to the x. So what does 2 to the x look like? It has a y-intercept of 1. It has a horizontal asymptote at 0 that it's flattening out to. So this is my parent function to the x. Okay, so that's step 1. Step 2 is figuring out, what is this negative going to do to my function. So we have to figure out which of these is going on. So the negative is right next to the input value. It's not out in front of the whole function. It's not out in front of the whole outputs. It's just right next to the input value. So that tells me that this is a reflection over the y-axis. So I'm going to take this graph, I'm going to reflect it over the y-axis. So this part of the graph is now up here. This part that was flattening out on the negative x-axis is now going to be over here, flattening out at the positive x-axis. So this would be the graph 2 to the negative x. All right, watch the next video for some more examples.